Welcome to Avitech Online. One of the most common laws of physics applied to aircraft systems is Bernoulli's principle. This clip covers the basics of Bernoulli's principle and how it relates to aircraft in flight. Along the way, it also shows some simple demonstrations that can be done at home to prove that Bernoulli's principle really works.
Have you ever wondered how an aircraft weighing thousands of pounds can fly? Aircraft can carry passengers and cargo thousands of feet through the air. Could the reason be that massive aircraft engines produce thousands of pounds of thrust? Or could it possibly be because of massive wings that can measure over 200 feet in width? How do superliners, which can weigh over 1 million pounds, take off and fly? Would you believe it's because of a principle discovered by the scientist Daniel Bernoulli in the 1700s? Bernoulli's principle explains the relationship between the pressure, the volume, and the velocity of a fluid in motion. Simply stated, Bernoulli found that the velocity of a given volume of fluid in motion is inversely proportional to its pressure. In other words, as the velocity of a fluid increases, its pressure decreases. As both gases and liquids are classified as fluids, we'll use air to demonstrate this principle and see if we can gain understanding as to how planes fly. One of the simplest ways to show this principle is to use a sheet of paper. Hold the sheet of paper up to your lips and blow across the top surface of the paper. You will notice that as you blow, the paper rises. Because you are blowing air across the top of the paper, the velocity of the air moving over the top of the paper is greater than the velocity of the air underneath. Bernoulli stated that the greater the velocity, the lower the pressure. By blowing over the top of the paper, we increase the air velocity across it and create an area of low pressure. The pressure on the bottom of the paper is now greater, causing the paper to rise. Next, let's place a venturi restriction in the path of a moving airflow. As we are sending a given volume of air past the venturi, the entire volume must pass through or around the venturi. Look at what is happening to the air as it passes through the venturi. If we consider 3 molecules of air passing around or through the venturi, we must note that all 3 must meet at the other end at the same time. For interior molecules to reach the end of the venturi at the same time as the molecules traveling the straight path around, they must travel faster. The molecules traveling through the venturi have a greater distance to travel than the molecules going around it. As velocity increases, pressure decreases. This increased velocity causes pressure to decrease in the center of the venturi, while it remains the same on the other end.
To further explore this principle and see how it is applied to other aircraft components, you can go to the complete online course, along with many other educational programs, on the web at www.avitech-online.com. You can also see our complete list of textbooks, reference materials, and training equipment, especially designed to support AMT schools at www.avitech.com.